On February 4, 2025, the USS Preble DDG-88, an Arleigh Burke-class destroyer, successfully demonstrated its advanced high-energy laser with integrated optical Dazzler and surveillance HELIOS system by engaging and destroying an aerial target drone. This notable achievement was detailed in the Pentagon's annual Director Operational Test and Evaluation DOT report for fiscal year 2024, which emphasized the test's objective of validating the HELIOS system's functionality, performance, and capabilities. Overview of HELIOS. The HELIOS system, developed by Lockheed Martin, represents a significant advancement in naval defense technology. Designed to counter modern threats such as drones and missiles, HELIOS operates by delivering over 60 kilowatts of directed energy. This energy is potent enough to incapacitate drones rapidly by heating their structures until they fail, effectively destroying the target. Additionally, the system features an optical Dazzler that can confuse or blind incoming threats, enhancing the ship's situational awareness and defensive capabilities. One of the key advantages of HELIOS is its cost-effectiveness compared to traditional missile interceptors, which are not only expensive but also limited in supply. The U.S. Navy aims to reduce its reliance on finite missile stocks by integrating directed energy weapons like HELIOS into its operational framework. Testing and deployment. The USS Preble, which relocated its home port from San Diego to Yokosuka, Japan in October 2024, is currently the only destroyer in the Navy equipped with the HELIOS system. The DOT report did not specify the exact date or location of the HELIOS test, however, it reaffirmed the Navy's commitment to integrating laser technology into its operations amid the increasing prevalence of drones in modern warfare. The successful test of HELIOS comes at a time when the Navy faces persistent threats from drone attacks, particularly in regions like the Red Sea and Gulf of Aden, where adversaries have employed drone swarms and missile threats. The successful engagement of a drone during the test signifies a crucial step toward operationalizing laser weaponry aboard Navy vessels. Technological significance. The HELIOS system exemplifies a strategic shift in naval defense, moving away from conventional missile interceptors towards more modern solutions like directed energy weapons. This transition is particularly critical given the evolving landscape of warfare, where drone technology has become increasingly accessible to state and non-state actors alike. HELIOS is designed to integrate seamlessly with existing naval systems, notably the Aegis combat system, allowing for coordinated defense against various threats. Lockheed Martin has indicated that the system is scalable, with future upgrades potentially increasing its power to 120 to 150 kilowatts, thereby enhancing its effectiveness against more complex threats. Challenges and future prospects. Despite the successful test, the development and deployment of laser systems like HELIOS are not without challenges. Factors such as operational usage, technology transition, and environmental conditions that affect laser performance have contributed to delays in broader implementation across the Navy. Nevertheless, the pressing need to enhance naval capabilities continues to drive efforts to advance laser technology. The U.S. Navy faces multiple challenges in transitioning these technologies from the lab to operational use. A 2023 Government Accountability Office (GAO) report highlighted difficulties in aligning the development of new technologies with operational needs, underscoring the necessity for early transition planning. Conclusion. The successful testing of the HELIOS laser aboard the USS Preble marks a pivotal moment in the U.S. Navy's directed energy initiatives. As the military landscape evolves with the proliferation of drones and other advanced weaponry, HELIOS represents a promising solution for addressing contemporary threats while ensuring operational flexibility and cost-effectiveness. With the increasing emphasis on integrating high-energy lasers into naval operations, the U.S. Navy is well positioned to expand the use of such technologies in maritime defense. As the military continually adapts to new challenges, the development and deployment of systems like HELIOS may play a crucial role in shaping the future of naval warfare. Counterintuitive information. 1. Stealth and visibility. while the HELIOS laser weapon operates silently and invisibly with the only visible effect being flames resulting from the target's destruction. This contradicts common perceptions of weapons, which are often associated with loud explosions and visible projectiles. The quiet and invisible nature of laser weapons might lead to underestimating their impact in combat scenarios. 2. Cost-effectiveness versus advanced technology. Despite the advanced technology and significant investment in laser systems like HELIOS, the reliance on these systems for cost-effectiveness contrasts with the high initial development costs. While laser weapons can reduce the cost per engagement by avoiding expensive missile launches, the upfront costs and technological challenges may not yield immediate financial benefits in the short term. 3. Single target engagement. Laser weapons are often perceived as high-tech solutions capable of addressing multiple threats simultaneously. However, HELIOS is limited to engaging one target at a time and requires a sustained energy application to be effective. This limitation challenges the expectation of lasers as a panacea for modern warfare's multi-target scenarios, particularly in situations involving drone swarms. 4. Environmental vulnerability. The effectiveness of the HELIOS system is heavily influenced by atmospheric conditions, which is contrary to the expectation that advanced weaponry would operate optimally in all scenarios. This dependency on environmental factors can hinder the system's operational readiness and effectiveness in diverse combat situations. 5. Delayed deployment. Despite the urgent need for effective defense against drone swarms and missile threats, the HELIOS system has faced significant delays in deployment and integration into the Navy's operational framework. This counterintuitive situation highlights a disconnect between military needs and the pace of technological advancement and procurement processes. 6. Complexity of transitioning technology. The transition from laboratory testing to field deployment for laser weapons like HELIOS is fraught with complexities, often resulting in misalignment with operational needs. This contradicts the assumption that once a technology is developed, it can be easily integrated into military operations. 7. Perception of laser weapons. The general expectation surrounding laser weapons is that they represent a revolutionary change in combat dynamics. However, experts describe their current applications as primarily suited for low-volume point defense against limited target sets rather than as comprehensive solutions for modern warfare challenges. 8. Energy source limitations. Although laser systems are promoted as using renewable energy, the practical aspects of energy generation and storage for sustained operations pose significant challenges. This fact contradicts the notion that deploying such systems would be straightforward and devoid of logistical concerns. These points reflect the complexities and contradictions inherent in the adoption of advanced laser weapon systems like HELIOS, revealing the multifaceted challenges facing modern military technology. The successful testing of the high-energy laser with integrated optical Dazzler and surveillance HELIOS aboard the USS Preble DDG-88 marks a pivotal shift in naval warfare capabilities. While many aspects of this development have been covered extensively in various reports, certain significant details are often overlooked that highlight both the strategic implications and technological challenges of integrating laser systems into naval operations. Overlooked aspects of the HELIOS development. 1. Long-term strategic shift. The HELIOS system represents not just a technological advancement but a fundamental change in military strategy. The Navy's decision to prioritize directed energy weapons over traditional missile systems is significant. The cost-effectiveness of lasers, given that each shot costs a fraction of a missile, addresses the growing concern of depleting missile stocks during prolonged engagements. This is particularly relevant in light of recent military engagements where the U.S. Navy has encountered drone swarms, which can quickly exhaust conventional munitions. The shift to laser-based systems aligns with a broader trend in modern warfare towards systems that can deliver sustained firepower without the logistical burden of traditional munitions. 2. Integration with existing systems. The integration of HELIOS with the Aegis combat system is often mentioned but deserves deeper emphasis. This capability allows for a multi-layered defense against a variety of threats, drones, missiles, and other aerial targets, by coordinating the strengths of both traditional and new technologies. The ability of HELIOS to function effectively within the Aegis framework enhances situational awareness and operational flexibility, which are crucial in high-stakes environments such as the Indo-Pacific theater. This integration is not merely technical. It symbolizes a strategic evolution in how naval forces will coordinate their defenses in the face of multifaceted threats. 3. Environmental and operational constraints. While the reports highlight the effectiveness of HELIOS in shooting down drones, they often downplay the environmental factors that could impact laser performance. Atmospheric conditions such as fog, rain, or dust can significantly reduce a laser's effectiveness, a limitation that becomes critical in real-world combat scenarios. The understanding of these constraints is crucial for operational planning, as commanders must consider when and where to deploy laser systems versus traditional weaponry. This aspect underscores the importance of continued research and development to enhance the robustness of laser technologies against a range of environmental challenges. 4. Military and industrial collaboration. The timeline of HELIOS development, from contract award to deployment, reflects the complexities of military-industrial collaboration. Lockheed Martin's initial contract in 2018 and subsequent delivery illustrate the lengthy process of bringing cutting-edge technology from concept to operational status. Such collaborations often face bureaucratic hurdles, and recognizing these challenges is essential for understanding the pace of technological advancement in the military. The successful deployment of HELIOS could serve as a case study for future military projects, emphasizing the need for streamlined processes and adaptive strategies to meet emerging threats. 5. Potential for future scaling. The scalability of HELIOS to higher power levels up to 150 kilowatts opens up discussions about its future capabilities. While current tests have demonstrated its effectiveness against smaller aerial threats, higher power levels could enable engagement with more formidable targets, including anti-ship cruise missiles or even manned aircraft. This potential for scaling highlights a pathway for continuous improvement in naval defense systems and could fundamentally alter the balance of power in naval engagements. Observers should monitor how this scaling impacts the Navy's overall strategy and operational concepts. 6. Global context and competitive pressures. The urgency to develop and deploy HELIOS reflects broader geopolitical dynamics, particularly the rise of adversaries like China, which is reportedly pursuing similar technologies. The narrative surrounding HELIOS should be contextualized within the global arms race for advanced weaponry, highlighting the need for the U.S. to maintain technological superiority. The acknowledgement that other nations are also investing in laser technology should prompt discussions about collaborative defense strategies and the potential for arms control agreements regarding directed energy weapons. Significance of these insights. Understanding these overlooked aspects of the HELIOS program is essential for comprehending the broader implications of modern military technology. The transition to directed energy weapons is not simply about replacing existing systems. It involves rethinking strategic frameworks, operational tactics, and international military dynamics. The ability to engage threats economically and effectively while minimizing collateral damage positions laser systems like HELIOS as critical components of future naval warfare. As the U.S. Navy continues to integrate these systems, the focus should not only be on immediate capabilities but also on the long-term implications for global security and military strategy. In conclusion, the HELIOS system aboard USS Preble signifies a transformative moment in naval warfare that demands careful consideration of its strategic, operational, and technological ramifications. The U.S. Navy's commitment to advancing directed energy weapons reflects a proactive approach to modern threats, emphasizing the importance of innovation in maintaining maritime security. 1. Technological significance of HELIOS. The high-energy laser with integrated optical Dazzler and surveillance HELIOS system represents a transformative shift in naval defense strategies. Unlike conventional missile interceptors, which are costly and limited in their availability, HELIOS offers a cost-effective alternative capable of engaging aerial threats like drones and missiles. With over 60 kilowatts of directed energy, the system can incapacitate drones effectively by heating their structure. This capability is particularly crucial in the context of modern warfare, where drone swarms and missile threats have become prevalent. The ability to produce a laser beam that operates silently and invisibly enhances operational stealth, allowing naval forces to defend themselves without revealing their position. 2. Integration with existing systems. HELIOS is designed to function in conjunction with the Aegis combat system, which allows for coordinated defense against a variety of threats. This integration is vital for the U.S. Navy as it expands its capabilities to address multifaceted threats in a complex battlefield environment. Furthermore, Lockheed Martin has indicated that HELIOS can be scaled to deliver up to 120 to 150 kilowatts, enhancing its effectiveness against more sophisticated threats. This scalability ensures that the system can evolve with emerging technologies and threats, maintaining the Navy's competitive edge. 3. Operational challenges and future prospects. Despite the promising advancements represented by HELIOS, the development and deployment of laser systems face significant challenges. Issues such as operational usage, technology transition, and environmental factors affecting laser performance have slowed broader implementation. The Navy's struggle to integrate these systems into active operations reflects a broader challenge within the Department of Defense to transition innovative technologies from the lab to the field. While the urgency for enhanced naval capabilities continues to drive the development of laser technology, the timeline for widespread deployment remains uncertain, underscoring the complexities involved in modern military procurement and operational alignment. 4. Global context and strategic implications. The deployment of HELIOS on the USS Preble coincides with a growing global trend in military modernization, particularly concerning directed energy weapons. As adversaries like China and Russia develop their own laser capabilities, the U.S. Navy's advancements with HELIOS underscore a critical need to maintain technological superiority. The proliferation of drones and loitering munitions among both state and non-state actors has heightened the urgency for effective countermeasures, making systems like HELIOS essential components of future naval operations. This situational dynamic reflects the broader strategic landscape, where innovations in warfare technology will play a crucial role in shaping military capabilities and deterrence strategies. 1. The U.S. Navy's Laser Weapon System laws. In 2014, the USS Ponce became the first ship in the U.S. Navy to deploy a laser weapon system known as the Laser Weapon System laws. This system was used to engage various targets, including drones, and demonstrated the potential of directed energy weapons in naval operations. The laws, developed by the Naval Sea Systems Command, showcased the ability to disable small boats and aerial threats by focusing a high-energy laser beam on them, effectively proving the effectiveness and cost efficiency of laser technology in a military setting. 2. Aegis Ballistic Missile Defense System. The Aegis system, developed by Lockheed Martin, represents a significant advancement in naval defense technology. Initially deployed in the late 1980s, it integrates radar and missile systems to detect and intercept incoming threats. The Aegis system has evolved to incorporate various weaponry, including the potential integration of directed energy weapons like HELIOS. It showcases how traditional missile defense strategies can be enhanced with modern technologies, paving the way for innovative solutions to counter evolving threats. 3. The Israeli Iron Dome. The Iron Dome is a mobile all-weather air defense system developed by Rafael Advanced Defense Systems, designed to intercept and destroy short-range threats such as missiles and artillery shells. Operational since 2011. It uses a combination of radar and interceptor missiles to protect populated areas from incoming attacks. The Iron Dome's success in real-world scenarios has underscored the importance of advanced defense systems in modern warfare, similar to the Navy's focus on integrating laser systems like HELIOS to counter aerial threats. The successful testing of the HELIOS system aboard the USS Preble DDG-88 marks a significant advancement in naval warfare technology, particularly in the realm of directed energy weapons (DEWs). As the U.S. Navy continues to integrate laser weapon systems like HELIOS into its fleet, several predictions can be made about the future of naval warfare and military capabilities. 1. Increased adoption of directed energy weapons. The HELIOS system represents a shift from traditional kinetic weapons to DEWs. In the coming years, we can expect the U.S. Navy and other armed forces worldwide to significantly increase investments in laser weapon systems. The advantages of DEWs, such as low operational costs, virtually unlimited ammunition dependent on power supply, and rapid engagement capabilities, make them attractive alternatives to conventional missile systems. With the anticipated scalability of HELIOS to 120 to 150 kilowatts, the Navy will likely deploy more powerful versions of laser weapons that can effectively engage a broader range of threats. 2. Enhanced counter-drone capabilities. With the proliferation of drones on the battlefield, the ability to counter these threats effectively will be paramount. The HELIOS system's performance in neutralizing aerial drones demonstrates its potential to become a primary tool for naval forces facing swarm tactics. Future naval engagements will increasingly see laser systems deployed to protect vessels from not only drones but also other unmanned systems used by adversaries. 3. Integration with advanced combat systems. The integration of HELIOS with the Aegis combat system is a clear indication of future naval combat strategies. As DEWs become more common, we can expect further advancements in automated threat detection and response systems, allowing ships to engage multiple threats simultaneously. The combination of artificial intelligence with laser systems will enhance situational awareness and decision-making processes during combat. 4. Global competition and development. Other nations, particularly China and Russia, are also investing in laser weapon technologies. The ongoing development of similar systems by these countries will likely spur an arms race in DEWs, leading to new advancements and capabilities. The U.S. must remain vigilant and innovative to maintain its technological edge, leading to further research and development initiatives. 5. Challenges and limitations. Despite the advantages, DEWs face several challenges, including atmospheric interference, power limitations, and the need for robust targeting systems. As laser technology evolves, addressing these challenges will be critical. Future research may focus on enhancing the range and effectiveness of DEWs under various environmental conditions. 6. Strategic military doctrine changes. The integration of laser systems into naval tactics may prompt a re-evaluation of military doctrines. As the effectiveness of DEWs increases, traditional strategies centered around missile usage may shift toward hybrid approaches that combine DEWs with other weapon systems. This could lead to new concepts of operation where laser systems play a central role in both offensive and defensive strategies. 7. Cost-effectiveness and sustainability. With the rising costs of missile systems, the Navy's focus on cost-effective solutions will lead to more widespread adoption of DEWs. The operational cost per shot for laser systems is significantly lower compared to traditional munitions, making them attractive for long-term sustainability. This financial aspect will likely drive further investment and deployment across various platforms. 8. Public perception and ethical considerations. As laser weapons become more prominent in military arsenals, public perception and ethical considerations surrounding their use will come into play. The implications of using such technology in warfare, particularly concerning collateral damage and the potential for escalation in conflicts, will require careful management and transparent policies. Conclusion. The HELIOS system aboard the USS Preble exemplifies a pivotal moment in modern naval warfare. The future will likely see an increased reliance on DEWs as nations strive to enhance their military capabilities in an increasingly complex and contested environment. While challenges remain, the potential benefits of laser weapon systems will drive innovation and strategic shifts in military doctrine, shaping the future landscape of naval engagements.